So we want to determine if the sequence is increasing or decreasing, or if it's not monotonic, and then also determine if it's bounded. So to decide if it's increasing or decreasing, let's look at the terms. If we look at the nth term and we compare it to the n plus 1 term, that would be, comparing it to one term after, we see that this denominator is going to be 4n plus 5 when we distribute that through and combine those. So numerators match. Let's compare the denominators. If we have 4n plus 1 and 4n plus 5, it's pretty obvious that 4n plus 1 is less than 4n plus 5. Now if we take their reciprocals, let's think about what happens with reciprocals, and maybe an easy example just so we can see. If we had 2 is less than 3, when we do the reciprocals, we see that the inequality sign needs to go the other way, because if the denominator is smaller, the fraction itself is larger. So we see that. And so in this particular case, this is going to be true. And then we could multiply both sides by 3. And so we would see that as we look at terms in this sequence, the nth term, so a term in front of the n plus 1 term, is always greater. So that tells us that this sequence then is decreasing, because any term is greater than the term after that. So now if we want to decide if it's bounded, well, if the sequence is always decreasing, then the very first term must be the largest term. So if we figure out the first term, that's going to be 3 over 4 plus 1, so 3/5. So our sequence is going to be bounded above by 3/5. In fact, the only time it is 3/5 is for the first term. Now if we're looking at a lower bound, let's actually take this sequence and let's see what happens as we let n go to infinity. So we have 3 over 4n plus 1, and in looking at that, this is staying constant, the numerator, and the denominator is going to become larger and larger, so this limit is going to be 0. So the terms are going to go to 0, and so that is our lower bound. So yes, this is a bounded sequence, bounded below by 0 and above by 3/5.